Since NumPy package is specially developed for mathematical and numerical computations, it has numerous operators and functions to perform special arithmetic and algebraic operations according to the laws of vectors and matrices. First, let's see the by-element operators. They perform operations like addition, subtraction, multiplications on corresponding elements of two similar arrays. For example, let's say A and B Now let's go through them one by one quickly. So as you see, it performed the operations element by element. If we look to the multiplication, it multiplied corresponding elements, but it is not exactly what we know as matrix multiplication. For matrix multiplication, we need to use the dot product function, which is dot, and in this format. So let's define two arrays. So A is a 2 by 4 matrix. B is 4 by 3 matrix. So let's try, let's say C equals to A dot B. We got a C which has 2 rows and 3 columns according to the rule of matrix multiplication. However, if we try the opposite, if we try to say we get an error message because the shapes or the dimensions are not aligned. That means they are not correct for matrix multiplication, because as we know in matrix multiplication, the inner dimensions, that means the number of columns of the A matrix must be equal to the number of rows of the B matrix. Now the matrix transpose converts rows to columns and the columns to rows. So we have now this example matrix A. So let's try to have its transpose. The first row became the first column, the second row became the second column, and so on. Determinant operation is one of the important operations in linear algebra. For that reason, we see that the function is a part of the module linear algebra. So for that reason, we need to call the module after the alias of NumPy. Let's try to find the determinant of this A matrix. The inverse matrix can be found by using the function inv from the, again, module of linear algebra. Let's try it here. So this is the inverse matrix of A. In order to be sure, let's do something simple. And let's multiply A by its inverse. We got the identity matrix. Now it may look very weird because we have these numbers, but notice the exponents or the exponents are very, very small. They approach 0. And we see the values of ones in main diagonal. The next one is the eigenvalue and eigenvectors. B equals to it is divided to two parts, so it is actually a tuple. Let's do it in a better way. Let's try to reduce the size of A. So let's say so in this way we made a smaller matrix, 3 by 3, and let's use V and M. So when we see V actually is the eigenvector of this of the matrix A, and as you see the elements are complex. And when we check M, again it is 3 by 3 because they are long numbers. It appeared in this way, but still it is 3 by 3 eigen matrix.